In this video, I would like to show you how to use simple moving average to forecast a time series with a constant level. Before we begin, let's click and drag this graph out of the way. And here in these columns, I want to generate simple moving average forecasts with different number of periods. For example, n equals 2, n equals 3, n equals 4, n equals 5. So the strategy is to try forecasting using different number of periods and trying to see which one gives you the best forecast quality. Okay, so let's start with n equals 2. What this means is that to generate this forecast, we need 2 time periods. Okay, so we will not have the necessary information for period 1 and for period 2. The earliest period we can forecast is period 3. Okay, so we will start here. I type n, okay, and then I type average. Average is a function, open parenthesis, and I'm going to select the first and second periods. Okay, so I'm going to take the average of the first 2 periods and then close parenthesis, press enter. Okay, so this is the average of the first 2, and then I come to the lower right corner, click and drag. Okay, so these are the averages of the most recent 2 periods. For example, for this period 4, when I click on the formula here, it shows me that it takes the average of the most recent 2 periods. I come here randomly, let's say, I click on the formula up here, and I see that it's the average of these 2. So I come to the last period, period 20, and I click here, and it takes the average of period 18 and 19. Okay, so this is my simple moving average forecast with n equals 2. Okay, let's generate simple moving average forecasts with n equals 3. So I cannot generate forecasts for the first 3 periods, and I can start with 4. So I'll say equals average, open parenthesis. I select the first 3, close parenthesis, click enter. Okay, and then I come to the lower right hand corner. I double click. Okay, these are the averages. And then well, you can, before I move to n equals 4, let's format these. Okay, so what I will do is I come to this number, right click, select number, decimal places equals 2. I click OK. So now all the numbers have 2 decimal places here, which look much nicer. I will do the same thing here for n equals 2. Number, okay, again. Here, for n equals 4, I come to period 5, type equal, average, open parenthesis. I select the first 4, and then I close parenthesis, enter. Okay, and then I double click, and then for n equals 5, I click here, say average, open parenthesis. I select the demand for the first 5 periods, close parenthesis, enter. Okay, double click. Okay, so and then I just select both columns, number, 2 decimal places. Okay, so these are my forecasts, simple moving average forecasts with n equals 2, n equals 3, n equals 4, n equals 5. Okay, so what we can do is we can add these forecasts onto this plot, onto this graph. So how do we do that? I come over the graph, right click, and then I say select data. Okay, and then here I have legend entries series. Okay, so I click on add. Okay, the time series name here will be n equals 2, and the values, the y values here, I click on here, and then I select these. I click again. Okay. So now what I have is the blue line shows you the actual demand. The red line shows you the forecast. Okay. Let's add n equals 3. So I click on add. The time series name will be n equals 3, and y values, I also select these empty cells. Okay. Say okay, and then I click OK. So now we have the gray line. Okay, and then I click on add. This is gonna be n equals 4, and then I click on the y values. I select everything here, including the empty cells. Okay, and then lastly I add n equals 5. Okay, n equals 5, and then click here. Okay, okay. So now I have kind of a difficult to discern graph. So what I want to do is I want to add legend. Okay, so I click on design, or okay, it's not here. So format. I should see some change colors. Should be somewhere here. Chart elements. Okay, I want to have legend on the right. Okay, so now this tells me which color represents demand, which color represents n equals 2, n equals 3, 4, and 5. They're kind of clustered in this area, so I want to magnify, expand this a little bit. So I want the y-axis to go from 25 to 35. Okay, because I know I don't need this part here, I don't need this part here. So I right click on here, any one of the numbers. I say format axis. Okay, and the bounds will be from 25 to, let's say, 35. Okay, and I click X here. So now what you can see is it's a little bit difficult, still difficult, but you see that the moving average forecasts are kind of fairly in the middle somewhere. Okay, in many cases, looking at forecasts visually like this will not give you a clear understanding which forecast is better. Just looking at this graph doesn't tell me which forecast is better. Okay, so, and this is an example of how you cannot tell it from a graph. So let's use numbers. Okay, let's use numbers, and let's calculate the error. Okay, so here I'm going to calculate the forecast error. Okay, what is the forecast error? The forecast error is, let me calculate the error here. Okay, equals actual demand minus forecast. Okay, so okay, I did this wrong. Okay, equals actual demand minus forecast. Okay, so my forecast was too high. Okay, and so I have this forecast, and I go to the lower right hand corner, click and drag all the way down here. Okay, so let's calculate the average. Okay, so the average will be so I calculate the average of my errors. Open parenthesis, and I select these errors. Enter. So what does this mean? This is the mean forecast error. Okay, let me write this here, mean forecast error. So some forecasts are positive, some forecasts are negative. This means that sometimes I overestimate demand, sometimes I underestimate demand. Okay, so what that means is that when I average them, the positive forecasts cancel out negative forecasts. Okay, and what I end up having is a mean forecast error. The thing is, I can have very large negative forecasts and I can have very large positive forecasts. But when I average them, they cancel out each other. And what I end up having is not a measure of accuracy, but a measure of bias. Okay, so the mean forecast error shows you not accuracy of a forecast, but the bias of a forecast. Okay, what is the bias of a forecast? The bias tells you whether a forecast on average over forecasts or under forecasts. Okay, so ideally you want to be right on target. You don't want to be systematically overestimating or systematically underestimating demand. Ideally, you want to be right at target. And so to avoid a positive or negative bias, you want to have roughly equal amount of positive errors and a roughly equal amount of negative errors. And when you have that kind of a situation, your mean forecast error will be close to zero. Okay, so now what we can do is we can calculate the mean forecast error, which is the bias, for different values of n, and then we can see which forecast error gives us the lowest bias. Okay, so here I'm going to say n equals 2, n equals 3, n equals 4, n equals 5. Okay, so when n equals 2, my forecast is minus 0.22. Okay, so I copy this, right click here, copy 1, 2, 3. I copy the values. Now let me change the formula and calculate this for n equals 3. Okay, so the formula here is okay, for n equals 3, I'm not going to have this cell, okay, because when I use n equals 3, I start here in this period. So I'm going to change this formula. I'm going to use demand, but instead of n equals 2, I'm going to use the forecast with n equals 3. I click enter, and then I come to the right hand corner and I copy this all the way down to here. Okay, so, and then the average stays the same. Okay, it's minus, let me copy this, copy, click here, paste 1, 2, 3. So I can see I'm farther away from 0. So the mean forecast error has increased in value, absolute value. Okay, so when n equals 2, my forecast is less biased. When n equals 3, my forecast is more biased. Okay, let's see what happens when n equals 4. Okay, so I delete this. I come to this number, which is the first forecast for n equals 4. And I click on the formula. So instead of, I'm going to use the same demand. Instead of this forecast, I use the forecast with n equals 4. I click enter, okay, and I click and drag all the way down here, okay, and then right click here, copy, and then I copy the mean forecast error here, copy 1, 2, 3. So now the mean forecast error has come down a little bit. Okay, so let's calculate the mean forecast error for n equals 5. Okay, I come here, delete this. So this is the first period when I use the simple moving average for n equals 5. I click on the formula, and now I move the forecast from n equals 4 to n equals 5. I click equals 4, right click, drag down to here, and what I see is a very small number. Right click, paste 1, 2, 3. So of all the forecasting, simple moving average forecast I have calculated here, I have the least bias when I have n equals 4. Okay, so in terms of bias, this forecast is the least biased forecast. Okay, least biased, in other words, positive and negative errors are roughly equal. Okay, least biased means that. Okay, and then, so this is bias. Let's calculate the accuracy. Okay, now forecast error doesn't give you accuracy because positive and negative errors cancel out each other. So for accuracy, we need to prevent that. Okay, to prevent that, there are two ways. One is we can take the absolute value of the error, okay, or we can take the square of the error. Okay, I adjust this, maybe here. So what I do here is I type equals, ABS, absolute value, and then I click on here. Okay, whatever is in that error cell, I take its absolute value. Okay, what does that mean? It means that positive numbers remain positive, negative numbers will become positive. So everything becomes positive. Okay, so let me go back to this, to here. So I go back, n equals 2. So this is n equals 2. I copy the formula all the way down here. So I have n equals 2. And here I have the absolute values of the errors. So 4 remains 4, minus 3 becomes 3, minus 4.5 becomes 4.5, 2.5 remains 2.5, 2 remains 2, etc. I click here, drag to the right. Now I have the average of absolute values. Okay, so this is called mean absolute deviation. Mean absolute deviation tells you how many units I'm off on average. For example, in this period, I was off by 4 units, positive or negative, because I'm taking the absolute value. Here I was off by 3. Here I was off by 4.5. Here I was off by 2, 5, etc. But on average, I was off by 3.33. Okay, so I copy, paste 1, 2, 3. Okay, so I was off by this amount on average when n equals 2. Now let's change the formula. Okay, so I'm deleting these. When n equals 3, let me fix the forecast error. Okay, n equals 3. The forecast error will be this. I right click and drag down. Okay, so this is my mean forecast error for n equals 3. And here I have the same thing, just negative numbers become positive, positive numbers stay positive. And this is my mean absolute deviation. I right click, copy, right click, paste 1, 2, 3. Okay, just to give this a bit more, a better look. Okay, I select this number, 2 decimal places. Okay, and here I do the same thing. Okay, number 2. Okay. So now when n equals 2, I'm off on average by 3.33 units. But when I use n equals 3, I'm off by only 2.82 units. Okay, so when I compare these two, n equals 3 and n equals 2 and n equals 3, n equals 3 is more biased, but it's more accurate. Okay, so this gives you a measure of bias. This gives you a measure of accuracy. Okay, so let's repeat this for n equals 4. Let's see if n equals 4 is even more accurate. Okay, for n equals 4, I delete these. I fix the error. Okay, so demand minus forecast with n equals 4, enter. I right click and drag down, left click and drag down, I'm sorry. And these are the errors, these are the absolute values, and this is the average. Okay, so I right click, copy, right click here, copy, I'm sorry, paste 1, 2, 3. So now between n equals 2, 3, and 4, the most accurate is still n equals 3. Let's calculate the accuracy for n equals 5. Okay, so I delete these. Okay, and I update the error. Okay, I copy the updated error all the way down to here. Okay, these are the absolute values. Okay, and right click, copy, paste here, 1, 2, 3. So comparing these numbers for n equals 2, 3, 4, 5, the lowest mean absolute deviation happens when I use n equals 3. So this is the most accurate forecast among the four, but it is the most biased. Okay, now we're going to talk about what to do in such a case in class. Okay, so there's another way to calculate accuracy. Okay, and for that, what I do is I use the square of the error term. Okay, so let's start with n equals 2, calculate the squared error, and take the mean average of the squared errors. Okay, mean squared error. Let's calculate mean squared error. So for that, first I go back to n equals 2, and then I fix the formula for the error term. Okay, I'm not going to bother about the absolute error at this point. Okay, so equals this error times itself, enter. So the error is 4, its square is 16, and then I drag it all the way down here. So error is -3, its square is 9, error is -4.5, its square is 20.25, etc. And then I come to the lower right corner, click and drag to the right. So this is the average of squared errors, or it is the mean of squared errors. Okay, so this is another measure of accuracy. Okay, so I calculated this for n equals 2. I right click, copy, right click, paste 1, 2, 3, paste values. So let's calculate this for n equals 3. So I delete these two. I update the forecast error. Okay, and I copy it down to here. Okay, and then okay, let me fix the format of these. Number 2 decimal places. Okay, so yes, so right click, copy, paste values, paste 1, 2, 3. So this is mean squared error when n equals 3. Let's do this for 4. Okay, update the values here, the error term. Okay, and then right click all the way down here, these are the squares, okay, squares, and then copy, right click, paste 1, 2, 3, paste values. Okay, so as you can see, the square of the errors, mean squared error, is decreasing as I'm increasing the number of periods that I use. Okay, let's calculate this for when I use n equals 5. Let me update this. So now my error is demand minus the forecast when I use n equals 5. I click, left click and drag all the way down here. I have these updated. Okay, right click, copy, okay, right click, paste 1, 2, 3, paste values. Okay, so in terms of mean squared error, n equals 5 is the most accurate. In terms of mean absolute deviation, this is n equals 3 is the most accurate. So these two accuracy measures don't give us the same, don't recommend us the same forecast. Okay. Now, in addition to these measures of accuracy, there's a third measure of accuracy, which is the most commonly used. And it tells you how far off you are on average in terms of percentage. Okay. So it is called absolute percentage error. Okay, so for each time period, you calculate what percent you are off. Okay, so what I do is I click on here, I take the absolute error, okay, absolute error, and then I divide it by the actual demand. Okay, this was the actual demand. I was off by this much, but what percent is that? Okay, I click here. And then to make this a percentage, I click on this percent sign here. And it tells me I was off by 1.4, which means I was off by 4%. So I click the same absolute percentage error for all these, and then I take the average by left clicking and dragging here. Okay, and I need to put this in a percent format. Okay, so this tells me on average I was off by 9%. Okay, let's do this for n equals 2. I fix the forecast error. Okay, so I fix the forecast error all the way down here, and then up here. So we can see that absolute percentage error is calculated by dividing 4 by 34, and that means in this period I'm off by 12%. In this period I'm off by 10%, 16%, etc. And on average I'm off by 11%. Okay, I copy and click here, right click, paste 1, 2, 3, paste values. Okay, and then I make this percent. Okay, so this is for when n equals 2. Let's calculate the same thing, mean absolute percentage error, when n equals 3. So I delete these. Okay, let me fix the forecast error. Now the forecast error is based on this forecast. Enter, and then I update the formula. Okay, this formula is automatically updated, and I see the average percentage error, absolute percentage error, goes down. Let's calculate this for when n equals 4. So I'll update this. Now I'm looking at n equals 4. I update the forecast errors. These are automatically updated. Okay. So sometimes when you use different forecasts, okay, they may have the same level of accuracy. Okay. So n equals 3 and n equals 4 have the same mean absolute percentage error. Okay, let me write it down here. Mean absolute percentage error. So both forecasts are on average off by 10% on any given period. And finally, let's do the same calculation for when n equals 5. Okay, so I'm looking at n equals 5, enter, and I update this. Okay, these are automatically updated, and this is 9. Okay, I copy this, click here. Okay, so now I can see that this has the lowest absolute percentage error. So in terms of accuracy, I have 3 measures: mean absolute deviation, mean squared error, and mean absolute percentage error. This accuracy measure tells me I should use n equals 3. Okay. However, this is low, but it's biased. It's the most biased forecast. But the other two tell me that n equals 5 gives me the most accurate forecast. Also, n equals 5 gives me the least accurate forecast. I'm sorry, the least biased forecast. So that's good. So among n equals 2, 3, 4, and 5, I should use n equals 5 because it's less biased, least biased, and it's most accurate. Okay? So when you replicate this in your assignment, okay, your numbers will be different, but I want you to generate forecasts using simple moving average with n equals 2, 3, 4, and 5. And for all of them, I want you to calculate the bias measure, mean forecast error. I want you to calculate these 3 accuracy measures, okay? And then I need you to decide which number of time periods should you use, which gives you the best forecast quality based on this kind of a table.